చేసుకోవచ్చు. సరే. ఇట్లుంటుంది ఆరో ప్లాట్ఫాము. హలో తరుణ్, వినిపిస్తుందా? ఓకే ఓకే. సో ఇక్కడ కంటిన్యూ చేద్దాం. అంటే దీని తర్వాత నేను మ్యూట్లో పెడతా క్లాస్ స్టార్ట్ అయినాక. నీకైతే స్క్రీన్ కనిపిస్తుందిగా? ఓకే. సో ఆయన రాగానే నేను ఇది క్లిక్ చేస్తా, వెబ్ఎక్స్ది. క్లాస్ స్టార్ట్ అవుతా ఉంటుంది. నేను నీకు మెసేజ్ కూడా పెడతా, కానీ జస్ట్ పింగ్ చెయ్యి ఎస్ అని. ఓకేనా? సో మనం ప్రస్తుతానికి ఈరోజు మెటీరియల్తో ప్రాక్టీస్ కూడా చేస్తూ ఉంటే ఇది మిస్ అవుతుంది. సో అందుకని ఏం చేద్దామంటే వాడు ఇది ఆన్ చేసినాక క్లాసుల కోసం ఇది పెట్టేస్తా. ఎగ్జాక్ట్లీ 9 అయితే 9కి స్టార్ట్ అవుతుంది అనుకుంటా. మాక 8:35 అవుతుంది. ఇంకో
is the slide deck on? I have 3 screens.
It's your slide deck, but the
it's
like, all right, that's what I intended there.
Okay, yeah. Sorry, అయితే. Yeah, bye.
Okay. All right. And yes, if you wouldn't mind, I would like the attendees to be able to speak so that they can verbally ask questions. Can we do that?
Yes, sure. Right, Sean.
Arrivals to roll in so that we can get everyone off on the right foot here. So let's just give a couple more minutes before we kick this thing off. Be able to take over at some point too.
Yes.
All right, great. Give everyone until 9:03 and then we'll get moving.
We have one from Germany, but he's not in yet.
Got an international workshop going on here. That's exciting.
Yeah.
Right, slowly but steady, people are trickling in.
It should be in the late afternoon or evening in Germany, right? 5 or 6 hours different?
It's 3 p.m. in Germany.
Yes.
We're getting close to that fun time of year where daylight savings trickles through the world, and then I never know what time it is for my European clients. It's always a fun couple-week period.
Yes, that's true.
Next year, I think we won't have in the US anymore switch back from daylight saving times.
No, I hope we can get rid of that. It's just quite confusing. And some states don't even observe that.
Well received. So we have a good time conducting this. We have 4 hours set out today. So what that means is that we have plenty of time to get through material, and we have plenty of time to answer questions and help you guys understand what R is, how this can help you in your day job, and hopefully make it a little less scary as we go through it. So we've requested for the setup that attendees do have the ability to talk on this, so you can unmute yourself to ask questions. I encourage you to do that. The best experience here is an engaged audience that asks questions, because chances are if you have a question that someone else in the audience likely will have that as well. This is an intro workshop, so if you're an experienced R programmer or if you've done quite a bit of work, this will probably be a little easier than you might expect. We're not going to go into the depths of advanced R programming. If you are a SAS programmer who hasn't really touched it, you've seen a lot of stuff about R, and you're wondering how to take your first steps into using R in statistical programming, then this is the place for you. And with great power of unmuting yourself comes great responsibility to please make sure that if you are not talking, that you are muted, so that we don't have that background noise. With me today, I have Jessica Higgins. Jess, do you want to introduce yourself quick?
Hi,
my name is Jessica Higgins. I work with Mike at Taurus Research. As he mentioned, we've done this workshop before. I really enjoy it. I hope you get a lot out of it. I will be monitoring the chat for any questions. If you have any there, you can send them to me directly or to the group as a whole. And then at some point, Mike and I will switch talking to give each other a break. And I'll lead you through some of the training as well. So I'm excited to be here with everyone today and looking forward to it.
Oh, by the way, are we, Sean, recording the questions? Just the questions with the answer, or?
I can keep a record of that if it doesn't happen automatically.
Good.
I will keep track of them.
Thank you, Jessica.
You're welcome.
And to back up a sec, because I did not introduce myself, my name is Mike Stackhouse. I'm the Chief Innovation Officer of Taurus Research. We do a lot of work in R. We've done a number of, released a number of R packages into open source that we have developed at Taurus. So we are quite passionate about trying to make this accessible and trying to do what we can do to make R useful for clinical research and statistical programming. So you do have this Q&A tool that we have here. So again, if you want to unmute and ask questions, I'm happy to answer that and take those questions verbally as well, but drop them into the Q&A tool and we will make sure that we get those answered for you. In the attendees, I do also just want to call out that we have Nick Maisel here from Janssen. He also volunteered to come in and help TA this for us as we go through. So you have quite a bit of our experience on the call. Jessica's been using it since R Commander was the dominant IDE back in at least over a decade ago.
You can say it. It's before 2010.
Before 2010. And Nick himself is a highly skilled package developer working in Janssen and innovation efforts that they have going on over there. Nick, do you just want to give yourself a brief introduction as well?
Sure. Thanks, Mike. And thanks for the kind words. My name is Nick Maisel. I'm based here in Raleigh, so I'll be at the single day event in person tomorrow. If you're there, please stop and say hey. I'm a SAS programmer for a decade, working at CROs here, and then now for freelance and R&D. So I was in your shoes a few years ago, so I understand your journey, and I'm happy you're here, and happy to help.
And I just want to express appreciation for Nick because he saw that we were conducting this and asked if we wanted an extra hand. And it's always great to have another developer here to help you guys and answer your questions. And again, we come from clinical research. We come from this stat programming world. So we're very familiar with how you guys are trying to use SAS in your day-to-day jobs. So we hope we can give you the best context as possible for learning R and taking your first steps in this workshop. So I sent out some material yesterday, and if you did not get that, there were, I sent out the RStudio Cloud environment I'm going to put this link in the, well, actually, I'm going to put the workspace sharing link into the call. Where do is there a way that I can publish material, or is there a way that I can send a chat out to the team or to the attendees here?
That is a Sean question.
Yes, you can. If you just go to on chat where you have the two, you can select hosts and panelists, everyone, or just particular people.
I don't see the everyone option here, Sean. Here, if I send you this link, can you send it out to the audience here?
Sure.
Yeah, I don't. To confirm, I also can't send any chats out to everyone.
Okay, so that might be a host-only capability. All right, so I sent that out via email to everyone who registered. So your email will be the setup instructions pre-workshop email that I sent. So that has access to the RStudio Cloud link. This is the workspace link that gives you access into the environment that we're using today. And then we have some brief setup instructions for you all of what you need to do. If you have not created your RStudio Cloud account, that's the first thing that I want you all to get started with. If you go to rstudio.com/products/cloud, and another thing, if Sean can put that out there in the chat, you'll click Get Started for free. It is a free account, so there is no charge. You just need an email address, and you'll be good to go. So you have the free tier. Select that. Oops. Ashton's going to be mad at me for that one. And go through with that. All right, crisis averted. Jess, I almost canceled the RStudio Cloud Instructor account I would have been in a lot of trouble with Ashley for that one. All right, so we also have this workshop website here, which I want you all to open on your machines as well. So putting that link into the chat. So at atorisresearch.com or github.io, enter to our website. The reason that this is useful for all of you is because we have all of the content from the slides that we're sharing today. This is a website that we leave up, so it is something that you can also take away and be able to use after we complete the workshop today as reference material. So everything verbatim that is in our slides is available on this website so that you can go through as well. So as we go through the material, it's something that you can have up to follow along with. As we talk today, it is something that you can look at after the fact to reference back to when you go back and you're using this hopefully in your day job at some point. So we have those two pieces of material. Sean, thank you for dropping those in the chat. And I see that a lot of you have activated your RStudio Cloud account. So there's a number of members that have made it into there. And then once we get into the body of this, then I'll show you about opening your project and how to do that. If you can just click into that access link that Sean posted there or that you received in my email, that grants you access to the workspace that we're using today. And we'll hop in soon enough to start explaining what that is, but it's going to be a working environment for you all with all of the packages are pre-installed so that you can use the RStudio IDE to do your programming. So the goals of this workshop that we're going through today, we have a few takeaways that we want you to get from this. So this is what I'm hoping that you obtain from coming to the seminar today. So the first thing is that R isn't scary. As a programmer, when you've been working in SAS for a decade and you basically know how to do everything that you're trying to do, approaching a new language can be intimidating. But we want this to be approachable. We want you to walk away thinking, I can use R to do things with data that I'm familiar with. I know how to do that proc sort in SAS, and now I know how to sort my data in R. So drawing some of those parallels and starting to understand that R is approachable, that learning another language isn't something to be terrified of. We want you to see that you can do clinical things with R. The same data manipulation, same output creation that we're doing in our standard SAS programs today. You can do clinical things with R too. The tools are there. The ecosystem in R is there. The IDE is something comfortable. So we want that to feel approachable. And then lastly, that you should be able to learn more, or that you want to learn more about R, and that this is something that you want to pursue. So we don't want to scare you off. We want you to feel comfortable, and we want you to feel excited about learning more and picking up more to do with this language. All right. So as I mentioned, we have the reference materials available on the Intro to R website link that we have there. All right, the poly looks like that's going, that's working for you now. So all the materials are up and available there. If you click on content as I'm going through the slides, that's where you'll find all of the slide content that we have there. If you missed some of the setup for the RStudio Cloud, we do have a brief little guide there about how to work that as well. I haven't updated that with the current workshop link for the RStudio Cloud project, but you have that in the chat at the moment. So, again, if you haven't created your RStudio Cloud account, now is the right time to start doing that. We'll have time to, when we start working on the first breakout, to go over that. But at the moment, I'm going to walk through the RStudio Cloud interface. So I can see here that a lot of you have already begun creating your accounts. So when you come in, the first place when you click on RStudio Cloud is going to look like this. You won't have any projects if you have a new account, but you'll see your workspace up in the top left, your projects here, and then this will likely be empty at the moment. By clicking the access link, so the one that Sean said, and in the chat it says from Michael Stackhouse to me at 9:11 a.m. That link will give you access to the workspace that we're using today. I have a number of those over here because we make active use of RStudio Cloud, but you're looking for down here when you click this little hamburger icon right here. You open that up and then you'll see PharmaSuck, RTP, SDE, dash, and then it's going to cut off the rest of the title. But this is the Intro to R workspace. So again, waffle icon, find this guy right here, and then this will bring you to the workspace. You're going to see something that looks like intro_to_R, and then we'll have assignment. And then all you need to do at the moment is just click it. And then it's going to open up, it's going to make your own copy of the project. So why is this helpful for the seminar today? Well, this is an independent programming area. So it creates your own little environment that has the R language, the R packages that you need to work today, and then it's going to open up the RStudio IDE for us to work in here as that pops up in a second. It's going to take a second to open, so just be aware of that. You're seeing that everything's waking up for me today, but then this is going to open up the RStudio IDE. So this is a playground for you guys to do all of the assignments, do your own testing work, and mess around with R. Everything that you do will not impact anyone else. So this is an independent area. It's not going to, if you break anything, it's only going to break it for you, and then we can help you fix that. But you don't have to worry about this messing with anyone else, and it's a safe place that you can mess around with the programming. So,
Hey, is there something special I need to do? Mine says the environment is empty when I click on that.
right, did you make it to the interface here?
I did.
All right, so this is Chip talking?
Yes, it is.
Same here, I cannot see anything in the environment.
So like the data sets
on,
I can't
yeah,
see.
it's gonna kick you out. Okay, all right, I see what you're saying. You're fine. So it's just I ran stuff after the assignment was created, or you pulled it down before mine was run. So this is Chip's environment. Chip, I just kicked you out, by the way, so you're gonna need to reopen it, but you'll just need to click back into it. So
is there a preferred browser here, Mike? This is Lavanya. I don't see the hamburger icon there to get into this environment for me. I just got to the projects and then it shows workspace, but then I can't go beyond that. I don't see the pharmaceutical single day even.
All right, so Lavanya, I'm gonna put the link in the chat again. It looks like you probably didn't click the workspace sharing link. So it's, I just put it in the chat to everyone. So do you see that?
Yes, and I clicked on the link.
Mm-hmm.
And it takes me to our projects. Okay, it's doing something here on my browser. It was running in the background. All right, thanks.
Okay, great.
Mike, I also see environment empty and I restarted, like I closed the browser and open in Dipali here.
Yep, that's fine. You don't need the data in your environment, so let me just restart my session to clean that out.
Okay.
Oh. All right, now my environment's empty. This is fine. You're good to go if this is the case, and we have everything here. So do not worry if it says environment empty. Everything is good to go there. All you're going to want is to make sure that you're in this Intro to R project, and that you have down here, you should be able to see the files that we're going to be working with today.
Hi, Mike. I just have one monitor, so I cannot work on it, right?
You can work on it because we're going to do, I'll do some lecture, I'll show you guys some stuff, and then you'll have some independent work that you can do. So you don't need to have the IDE up at the same time that I'm talking. All right, so I'm going to take a quick tour through the RStudio IDE for you at the moment. So to start with, the RStudio IDE is made up of a couple different panes that we have here. What you see right here is called the console. So in SAS, you're used to taking a chunk of code, you run something like a proc, or you run something like a data step, you hit the run statement, and then you can execute that code, and then it'll execute the code as it goes through. So R has this thing called the console, which is going to be you can think of it almost like your SAS log as it's executing things as it goes, but you do have the ability to type code into the console directly, but this is R evaluating step by step. So whereas SAS runs a chunk of code in one block, your data step or your proc together, and then it goes and it executes that data step. R executes line by line as you go through. This is a style of programming. The style of programming that R uses is generally referred to as functional programming, where functions execute one at a time, and then they go through and evaluate function by function. You'll see how that works as we get through more of this, and then I'll slides as it makes more sense. But what you can see here is that in the R console, we have the code that's evaluating. So I can type things like math equations that we have here. So 4 times 2 equals 8. I can assign my variables. And then those variables will be added into my environment. And I can print my variables so that they print down to the console, much like messages right into the SAS log as we go through. But this isn't generally where you'll be doing your programming, because just like we make .sat files, up here we have, when I went in and I created or looked at this little icon right here to create a new file, I can create an R script, and that opens up a new program file for me, which is currently untitled. This is going to work like you're used to writing your SAS programs, so I can have different sets of code up here. I can do the same things that I was doing in my console and add this into what will eventually become a .r file. And just like you have the running man in SAS, you have the run button up here, which will evaluate the code as it goes through. When you click that, it'll execute one statement at a time. And then I compare it to the console, to the SAS log, because you can see as the code is executing, that's where you can see the chunks of code that are being executed as I go through here. So this will continue to make more sense as we go through it, but I can execute these chunks of code as we go through and edit that file. So over on the right here, we have a number of different tabs. This one is quite important. It's called the environment pane. And that's going to tell you all of the variables that are currently in your environment. So you can think of this almost like your work data sets in SAS. So here I have a variable named x that carries the value hello. I can make my data set. And just like in the SAS help menu, there are some data sets that are built into R. Empty cars is one of those. That's also in SAS help. In that library that you have there, I've created a data set named my data set, and you can see that that pops over, and I can see that that's a data set with 32 observations and 11 variables. So as you create new variables, as you create new data in your R environment, that will show up in the environment pane so that you can see what's there and review what's available. When you have a data set, like my data set, that is in that global environment, you can click it. And then we have a data viewer. Just like when SAS pops out your working data sets, this is one of the data sets that's in my environment. I'm able to click it. And then I have this HTML table view, much like the SAS viewer in Enterprise Guide for when you're viewing a data set within PC SAS, so on and so forth. But I have this available so that I can see the variables and the data values in that table in my environment. So I can X out of that. There's a number of other tabs that are available here that can be useful. Everything that executes on your console will show up in the history. So if you need to look back and see different codes that you've executed throughout the course of your session, you can look through the history tab. Connections would store database connections, but we're not going to get into that today. RStudio does have a Git interface for when you're working with version control, but we're not going to touch any of that today. And then if you're ever using the RStudio IDE, they do have some built-in tutorials that you can use, and it'll walk through getting the Learn R package installed there so that you can check that out and get that working. All right, so down in the bottom right, you have a file explorer. So this is going to work just like the Windows File Explorer, where you have folders available so that you can go in. I have a number of different folders that we're going to go through today, including all of the breakouts that we'll have as working sessions where you guys will get to do some hand-on coding. But when you navigate into those, you'll see the different files that we have available here. And you can click these to open the different files. If you save a file, so there's a license for this, but I'm going to go ahead and say by file save as. Call this my program. And the folder that I'm currently in is Cloud Project. And then I have that there. And you can see my program.r has been saved down into the folder right in here. So this is just the general file explorer. You have much the same thing in SAS Enterprise Guide to be able to navigate as you go through there. If you're on Windows, it'll match up with your C drive and be able to explore that. If you're working on a server in the cloud, you'll be able to explore whatever mounted disks that you have here. But this is how you would navigate to find your files and open files as needed. I'm going to make a plot quick. Whoops. ggplot. I didn't load the library. ggplot 2, come on, Mike. Okay. That was going to be embarrassing really fast. I'm not a plot guy. So down here, I just made a plot using ggplot2. We're not going to get into plotting as much today, but in your pursuit of learning R more, ggplot2 is one of the most famous R libraries, and it's why people often look to R for its ease of creating graphs. But just to make a simple bar chart down here, the point of my embarrassing show of live coding, which never goes well when you have people watching you, is to show that we have the plot pane down here as well. When you create new plots, it's going to show down in this pane as well under plots. Additionally, in the bottom right pane that we have available here, you have packages. So what this menu allows you to do is see what is available and installed into what is available on your library paths in R. So we'll talk a little bit more about packages as we go through this. But to see what's installed and available to you, you have that here. If it's loaded, a checkbox will be put onto the left. So you'll see that I have ggplot loaded, or ggplot2 loaded, and that shows here because I have called the library there. More on that later.
Mike, how does it differ from RStudio that I install myself?
So the nice thing about RStudio Cloud is that this is basically exactly the same IDE. If you installed RStudio on your desktop, and so I have RStudio on my desktop, like right here. So it's the same exact IDE. It's going to behave pretty much exactly the same. So the difference being here that I chose a dark mode color scheme in that. But one of the nice things about the RStudio IDE is that whether you're using it on a server or whether you're using it on a desktop, it's very much so the same user experience. Does that answer your question, Alice?
Yeah.
All right. As you go through, there is this help menu that's available. If you put question mark and then a function, and then you execute that on the console, or if in the console you type help, and I'm going to type ggplot here. You have the function documentation associated with whatever function that you're trying to access. So this is really convenient for you to be able to go and see, all right, what does the function ggplot do? It initializes a ggplot object that can be used to declare, so on and so forth. It has the usage that shows you what the call to the function looks like. It'll detail all the arguments of the function and tell you what they're supposed to be used for. And then there can be more detailed sections to explain it further, and then examples that go with the function as well. So most R packages that you'd use on a daily basis do have quite good documentation, but this is really nice for when you forget exactly how a function is supposed to work, for you to be able to call that help menu and then look at the documentation associated with that, see some different examples for usage. And that will show down in this bottom right pane for the help documentation. All right. So for today, I created an R script right here. So an R script is going to be very much so the same as a SAS program. So it's R code that is going to be executed, and then it's going to go and do whatever you wrote that program to do. Today, in the files that we're using to go through and where you'll be entering your code, we're going to use something called R Markdown. So R Markdown combines the ability to create documents with the ability to execute code. So where I'm going to start with that is just to go and show you what the output of this document looks like. So in this file, and it can look a little confusing, but there are some basic components that we have to it. We have a header that has been written here. You don't need to touch any of this today, so you don't need to worry about it. And we don't need to go into detail there, but this is just things like your title, subtitle, and then some configuration options for how the document should be structured. We have these things called code blocks. So why is this important? Because this is where you're going to be executing your programs today. So we have the code blocks start with some backticks to symbolize that it's going to be a chunk of code. And then this little R that says that it's going to be R code. And then you name it, and then some other options on that. But you have this little code block here. I'm going to execute the code block, there is this play button that you see there, and that's going to say run current chunk. And then that's going to execute the code down at the console. And then we have text and then more code. So again, if I click this play button, it's going to load that data for me. So I'm reading data in here using this read XPT function. And I'll get back to that in a second. But you'll see that we have the text here, and then we have the code. What that ultimately allows us to do is create documents like this. R Markdown can do a lot of different outputs. You can create HTML documents, you can create Word documents, it can even go so far as to create slides or websites, different things like that. It's one of the really powerful tools within the R ecosystem, and it actually has a successor called Cordo at the moment, but the documents that we're working with today are called R Markdown documents. From a user perspective, Cordo and R Markdown are very, 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 very similar. So everything that you're learning about using these documents today would be transferable to that. But we have these breakout documents, and you can see that it prints the code, it prints the text, and then we're going to be able to see the different material as we go through and do that today. To render the entire document, just like we have the run button within the myprogram.r with these R Markdown documents, you're going to hit this little icon called knit. And it's called knit because it's knitting together the text and the code to create that final output that stitches everything together for you. So again, just to show that, I have this knit button. When I click that, it's going to push everything through, create my final document. But when we have these little code snippets, when you want to run that code, you can hit the play button here and it'll execute that for you. All right, so we're here to help as we're going through and answering questions as we go through the breakouts, but that was the first thing that we wanted to get through today, to show you guys the IDE and give you that brief overview. It's a lot to take in. Again, it's one of the reasons that we make this a 4-hour workshop, because I show you around and it's going to start crystallizing and making more sense as we go through and as we go over the material and you start using it yourself here. All right. So we're about 40 minutes in. Hopefully you've gotten your environment set up. So we're going to go into the first chunk of the basics of what R is, and it's just the basics of R itself. So in this section, what we're going to discuss are the object types in R, how you assign variables, what your operators look like in R, and what packages are, and what that means, because packages are a huge part of what makes the R language useful versus what you get from just the base language itself. So in R, we have one of the biggest things that you're going to interact with starting out, and what we're going to focus on within this workshop itself, are data frames. So data frames in R are like your data sets in SAS. So they're going to be made up of columns. So you have your variables in SAS. In R, data frames are made up of the terminology in R is called vectors. So they're treated like your columns in your column variables in SAS. There's a number of different data types that exist in R. There's and it being a language that has object-oriented capabilities, you can make your own data types when you need something to hold specific structure. But today we're going to focus on 3 different core variable types that you'll be used to, because they're go down to the same concept of the core variable types that you have in a SAS data set as well. So the basic variable types are numeric. So you have your numbers. That could be integers. It could be floats. Those things are stored slightly differently, but they both go down to numeric data types that are just generically going to hold a number. You have character variables. So that's going to store text, just like your text variables in SAS. It's going to store those character strings. Each cell is a different character string itself. An important note that I'll throw out up front is that character variables in R do not have lengths associated with them. So you're used to in your SAS data sets declaring what the length of a character variable should be, and then having to worry about that if your variable exceeds that length, or if you're going to truncate anything. In R, character variables don't have a limit on length. Each cell is just going to store whatever the string is, and the actual maximum length is something that would be very, very hard to hit in the first place. So you don't need to worry about character lengths. you just have your character variable. And then finally, R has another data type that is called Boolean. So this stores true or false. So you have Boolean variables, and we work with those in SAS, but it's an actual core data type that we have in R. So that's going to store true or false. Under the hood is pretty much 1 or 0 that you have. So it behaves much like a number, but you have the Boolean data type, and these are the 3 that we want you to focus on at the moment. From how this expands out, these are kind of the core fundamental data types. So just like in SAS, if you get into things like dates, dates are a number under the hood. Everything kind of expands out from these core data types fundamentally. But collectively, these are taken together to store into a data frame. So a data frame contains multiple variables. So in this data frame that we have here, you have variables A, B, and C. A is a numeric variable, B is a character variable, and C is a Boolean variable. So in R, when you assign a variable, there are actually 2 ways to do it. It looks a little quirky, but R has this thing called the arrow operator. So just like when I was working on the console earlier, when you want to assign a variable, if I want to create a variable called X, I can use X and then use the arrow operator and then assign that to the value hello. This also works with the equal sign, but there's really kind of underlying complex differences of why there are 2 assignments. So what we want you to take away from the moment is that if you're creating a variable in R, use the arrow, because this is the convention in R, and it's a habit to get into. You want to make sure that you're assigning variables using the arrow. So I want to see that from you all going through today. If you create a variable, use the arrow operator. And so that's just going to be the less than sign and then a dash. So you're pointing towards the variable that you're creating as you do that. So that's what's going to bind a variable into the environment. As I showed you in the program, if I can delete X from my environment over here, and I can just clear that out.
Mike, is that a habit? That's why we used it. That is the what is it? Less than sign and then the hyphen versus an equal, where you have to do 1 more stroke. What is the advantage?
It's 1 more stroke. So it goes down into like complex operations of how those things, of how that works in function calls, and how it works with how things are binding into the environments. I can find an article that explains this in more detail of why the arrow is a convention, but it is best practice to use the arrow operator because of how that works with technically binding the variable under the hood. Nick, is this something that you have off the top of your head of the like mechanical differences between the 2?
Yeah, it gets a little too complicated, I think, for an intro class. I pretty much just advise use the assignment operator, even puts 1 more stroke. Yeah.
Thank you.
If you're a nerd like me and you really want to understand the difference, this looks like a brief overview. I can't ever resist myself from going into these conversations, but it is a fairly dense explanation of what the difference is between the 2. And while it feels like an additional keystroke when you're looking at it initially, when you get into, let's say you want to develop a package and then you want to push it to CRAN, you would get pushback for using the equal sign in the wrong context of something like that. So there's, it looks like that article should cover the core features of that. But long story short, use the arrow, take that away. from today. If you want to create your variable x, and I'm assigning the variable x to hello, and then you can see that that is added into my environment. All right. So here's where we were from current slide. So now to go over the operators. So we're going to go over a number of different sets, but we have this table here to explain what each of those are. So if you're testing equality, if you want to see if two values are equal to each other, you're going to use the double equal sign. So if you've used other languages outside of SAS, these are going to seem familiar because languages like Python will generally use the same context here as well as other languages like C or Java. But the double equals means that value on the left is equal to the value on the right. So x equals y is going to see if x and y have the same value. The exclamation point equals is going to be not equal to. So in SAS, you would be used to the caret equals. So here you're going to use exclamation point equals is not equals to. So x is not equal to y. The less than sign is less than. So that one's straightforward enough. Less than or equal to. So you're going to have less than and then the equal sign for less than or equal to. And the same cases for greater than and greater than or equal to. So the greater than symbol comes first, and then if you want it greater than or equal to, you have the equal sign second. So there you have the core operators for testing equality. When it comes to arithmetic, generally these are going to be what you're used to. So the plus sign for addition, so 1 plus 1 equals 2. Would tell us that 1 plus 1 is in fact equal to 2. Minus for the subtraction, the star is your multiplication symbol. So 2 times 3 equals 6. The forward slash is division. So forward slash being division, 6 divided by 3 equals 2. Exponentiation has two options. You can either use the caret to symbolize that you're raising 3 to the second power, or you can also do 2 stars for exponentiation for that, so that those two values are going to be equal to each other. So 3 star 2 is going to be 3 to the second power, as is 3 caret 2, and both of those will equal 9. If you've used the modulo operator in the past, or modulus operator, which gives you the remainder that's left over after one value is divided by the other. So that is going to be 2% signs. So x percent y is going to be the modulus of 6 and 5, which is going to be the value of 1 because there's 1 left over when you divide 6 by 5. And then you have integer division as another operator here as well, which would be percent forward slash percent. So that's going to give you the rounded off value down to the integer portion of that number when you divide two numbers. So 7 integer division by 2 would be 3 because there are 2 times 3 equals 6, and that's closest to 7. And then there's a couple more options or operators that we want to introduce to our vocabulary here, which would be that the ampersand symbol is used for and. So if you need to have two conditions next to each other, you have x ampersand y. The bar is your or symbol. So you have x or y using the bar. Generally, the exclamation point is going to mean not. So the opposite, reversing the truth of whatever condition. So if you introduce the exclamation point before a Boolean variable that's going to say not that condition. And then %in is going to be how you use your in operator here. So we use that in SAS quite a bit if you need to check if, say, a value is within a list of different potential values. In R, you're going to use this %in percent operator here. You'll notice that there's quite a bit of use of percents that we have here. It's a special type of function for called magic functions, but essentially you'll see it a little bit as we go through here today. There's some mechanics to it that we won't get into, but just get used to seeing every now and then you're going to have these kind of special functions that are going to start with a percent, have something like in the middle of it, and then end with a percent. And that's something unique to our syntax. The term for it is magic functions, but there's a number of different use cases like the pipe operator that we have here that we'll get to next. So the pipe operator is a very special thing introduced in R, and it's really become a dominant view of how R code should be written. So much so that there is actually a new function. There's a native pipe introduced into R version 4.1 so this is something that started in an R package called McGritter and has made its way into the base language itself. Today we're going to use the McGritter pipe, and we're going to train on that. So I'm not going to try to confuse that too much. We're going to stick with this one for right now. But it's a special thing in R, and then the general idea here is that it can be read as and then. So whenever you see this % greater than % symbol, and that's really trying to symbolize that you're pushing forward, you can read it as and then. So this is a nice little tweet that captures the concept of what this is supposed to be. So the idea here is if you look at the sentence below, you see I woke up, % greater than %, showered, % greater than %, so on and so forth. But the way that you can read this when you're reading our syntax is to say, I woke up and then showered and then dressed and then glammed up and then took breakfast and then showed up to work. What's happening is you're pushing the output of your function into the next function. So it creates a very readable style of syntax that you'll start to see as we go through here today and get into the programming of everything itself. So this is called the pipe operator, and just start embedding that into your head now that when you see % greater than %, you're going to read that as and then. And then here, packages. So if you've worked in the SAS world, this isn't really something that you're going to be familiar with. That you're going to you're not going to be used to taking packages from any external source realistically, because SAS gives you everything that you're going to work with out of the box. But packages are collections of functions and tools to expand the capabilities of R. So what that means is that if I want other users to be able to use my code, I can share that with the R community in the form of a package. So I can write a number of different functions on a number of different tools and then say, all right, this is something that you can go and you can install into your installation of R. So they're a really important part of the R ecosystem because up on the go-to place to get these packages called CRAN, I think that there's about 17,000 user contributed packages. So it's a way that you can expand the language. It's a way that you can expand the capabilities of what R is able to do. But generally, it's like it's a collection of functions, because in R, if you want to, kind of like when you write a SAS macro, you can give that over to someone else, and then they're able to call that macro and then do some action. So the closest concept of that in R is a function. And then you can build up a collection of functions into a package, kind of like in SAS, you can make a macro repository, and then you can ship that macro repository to someone else in a macro repository.
Mike, how can you make sure that this package are what's it called, of quality?
That is a whole other conversation that I don't want to go down that hole today because I don't want to dominate the conversation with it. But the predominant concept on that has become a risk-based approach. And there are different ways that you can assess the risk of a package into understanding, into getting metrics and assessing how you can, whether or not that package is of quality. So there's a lot of different things that you can look at in there as far as risk goes. But that's a big conversation, Alice.
So anybody can put something in the package and get it published?
I would say yes and no. CRAN is not something that you can just make it to CRAN. CRAN is reviewed by humans. So that's an important thing to understand. That when you put a package into CRAN, that someone does review what you have submitted. There's a number of quality checks, upwards of 50, that you need to pass to be in compliance with CRAN. And over time, if your package is no longer compatible and those tests fail at some point in time, like on a new version of R, it will be removed from CRAN. So while it's while anyone is allowed to contribute to CRAN, there is a process of getting a package approved and then published to CRAN. Does that help to start with?
If a very new package comes out, it is used at your own risk then, basically.
Essentially, yes, and that's why there's a lot of organizational strategies to put in place to use this in an enterprise setting. So generally, if you're using R for clinical research, this would be something that there needs to be boundaries and guidelines that are put into use. There should be IT regulation around the environment to ensure that you are using it in a safe context. And there's a lot of different components that make that up.
Is there somehow that before I use a package, I can check that is how much QC work has been done on it?
That would be an organizational decision. So this would be something that your organization needs to establish practice with from the start. And granted, we don't just install SAS and run with it. There is a computer system validation process that's associated with that, and that's no different than what you should do for using R.
Okay. Thank you.
But that is a big topic. There's organizations like the R Validation Hub that have guidelines around assessing package risk. And it's been a big topic in the community probably for the last 5 years. But it is something that organizations are more and more actively getting the hang of. So once that package is available, if you want to load a package for use, so this is to say I want to use functions from my package, you would call library and then the name of that package, and then those functions would be loaded so that you're able to use them. So when we talk about quality packages, and when we talk about third-party contributors, we're going to be using packages from a collection called the Tidyverse. So the Tidyverse is a set of R packages for data science. So By definition, what the on the Tidyverse site, the Tidyverse is an opinionated collection of R packages designed for data science. All packages share an underlying design philosophy, grammar, and data structures. So the Tidyverse itself is supported by the organization RStudio, so this is something that does have commercial backing that supports the open source development that goes into these packages. What it means by opinionated is that one of the challenges of when you're working with a lot of third-party contributed packages is that people can design things different ways. I'm sure that you've seen macros that have been written one way, and you call the macro in a particular way, and then someone else might design their macros differently. So there is a paradigm that goes into the Tidyverse for how things should be written, how functions should be called, and that shares that underlying design philosophy. But, excuse me. So the Tidyverse has millions and millions of users that are using it on an active basis. So these are packages that are very robustly used. There's been tons and tons of input into the development, but what it makes for is a really great user experience for programming. So with backing of RStudio, you have these really high quality maintained packages that can do a lot of the fundamental data tasks that you need to work with. So this goes from things like string manipulation to how you are manipulating your data, how you're adding variables, how you're trimming back data sets and filtering them, how you're doing transpositions, and then plotting, and then different readers for reading from different sources. So we have a lot of really great packages in here, and we're going to introduce you to some of the fundamental packages in this seminar today. Alrighty. So let's get started with the first thing that I want you guys to do in here on your own. So you have that RStudio Cloud environment. So what I want you to get started with at the moment, and I'm going to walk through this. So we're going to open the file demo, demo.rmd. So I'll walk through this. All right, so in your screen, down in the bottom right pane, we have files. And we're going to come down, and then we have this folder called demo. You're going to click into that. So in here, we have demo.rmd. I'm going to open up that file. That file itself will open in the top left here, where you'll see demo.rmd opens. What you're going to do next is come down and scroll down. If you look on the left here, you're going to see line 11. So down over here is going to be the line numbers that you have available. So I was talking about our markdown documents earlier. This is called a code chunk. And like I mentioned to you guys just a moment ago, what this code chunk is doing is loading your libraries. So I'm going to load a couple different libraries that we have here. Tidyverse imports the core Tidyverse packages that I was just mentioning, and we're going to use those throughout the course of the seminar today. Haven allows you to read SAS data. So we're going to be reading XPT files, just like the ones that we submit to the agency. So those are going to be loaded from the package Haven. knitr is a package for our markdown, and we're not going to dig into that as much today. And then I'm going to load two packages developed by Taurus, which are tplyr and pharma RTF. Tplyr for doing clinical data summaries, and doing the data derivations for that, and then Pharma RTF to write out RTF documents. We're not going to be working with those today, but this demo file just shows you a little bit of what we can do in R and how that relates to the clinical work that we do. All right, so on line 11, the first thing you're going to do is hit the play button. And then you see that executes down on the console. If you scroll down here, after you hit the little green play button right here, you'll see that on the console, those lines of code have executed. So library tidyverse, library haven, library knitter, library tflyer, library pharma RTF. You might get some messages. What this is just saying is that the package is being attached. So the following object has been masked from package graphics. That's fine. You don't need to worry about those messages generally, and definitely not for the session that we're doing today. I'm just going to run that again. From a fresh session, because if you haven't executed anything, when you load tidyverse, that can, it has quite a bit of output here. So just explain this because those red X's can be scary for someone. Attaching packages, telling you all of the packages and their versions that are being attached. So that's just library tidyverse showing you I'm loading ggplot to version 3.3.6, so on and so forth. Down here it's showing conflicts. These conflicts aren't bad. This is not an error. That's just saying that dplyr filter is overwriting in your workspace the function stats filter. But we want that because when you call filter, you want that to come from dplyr. When you call lag, you want that to come from dplyr, not stats. So that's expected. This is how we want the environment to work. So just don't be scared of those red X's. When you do get errors in R, it'll start with the prefix error, just like you see in your log with SAS as well. So errors will explicitly state errors. All right, so the next step, if you come down to line 26, we want you to run that code too. This is going to process some data. So you're going to click that green chunk again. That'll do some stuff, and you'll see some data pop over into your right environment pane that we see here. You'll see the data set DM. You'll see the data set raw DM. So on the console, you'll see that that code has executed. If you didn't run line 11 yet, this is not going to work because we need to load our libraries first. So that's a habit that we want you to put in your head. If you're going to use code from a package, you're going to need to call library for that to work. So I ran that code. I'll do that again. Click the play button right that you see here. It's going to run some code for me down on the console, like my log writing out the SAS code that I've been executing. And then you're going to see two new objects in your environment, DM and raw DM. So over here, if you're not on the environment tab in the top right, click environment. You have your two data sets. And you see there those. If you want to open them, you can click it. And you'll be able to view your data in the data viewer here. So just make sure that you can do that. And then finally, the last thing that I want you to do is click this button that says knit. I'm going to do that. And this render tab is going to come up. And then we're going to have this document pop out. So this is the demonstration markdown file. And then you can scroll through this and look at some of the things that are going on.
Can you go back to, I'm sorry, can you show go where the knit button is again, where you did that?
When you're in the .rmd file, so if you have, this is the script pane that you have in the top left. If you click and you're in demo.rmd, you have this little knit button. It says knit right there. The symbol is a ball of yarn and a needle. So if you see that, so I'll do that one more time. To click knit, and then it does some things there. So take a couple minutes, go through this. Let's give about 5 minutes so that we can get into the next section. Play around with that. If you have questions, you can put them in the Q&A, or you can speak up here. I'm going to take a second and grab myself another cup of coffee. But Jessica and Nick, if you'd be so kind as to answer questions if users are struggling with that as well. But I will be right back from getting some coffee. So I'll bring this up on the screen. So 5 minutes, get in, do these instructions. If you, I'll leave the instructions of what I want you to do up on the screen right here. So get through that. Let us know if you have any issues.